Welcome dear students, we are on the CEC-UGC lecture and we are in the series of the electronic circuit in which we are discussing the printed electronics. In the printed electronics we have discussed the methods through which we can prepare the electronic gadget by using the various method which is based upon the printing technology. So now we will discuss the one of the important gadget, one of the important base that is used for the printing electronics, that is the substrate. So today we will discuss about the substrate for the printed electronics. Substrate is the base where we print the gadget or electronic circuit. Previously we have defined the ink, types of ink, and what are the requirement for the ink just to print on the substrate. So now in today's lecture we discuss the substrates which we are using for the printing electronics. So the substrate basically is a base for the rest of the electronics and act as an electric insulator to separate the electric devices from each other. Means we are having a base and on which just we prepare the different circuits, and these circuits work as an electric devices. Traditional substrates for electronics have been usually rigid and physically invariant for the indefinite time frames. So despite their high performance, they possess a brittle characteristics, making them difficult to use in implantable as well as the scratchable devices. So on the other hand, the development of the lighter, flexible and recyclable or biodegradable synthetic substrates which enables the advancement of electronic devices within which will be useful within the particular time frames. Means we are just making a device, a gadget that will work in a many time span, and it will also must be biodegradable so that it will not harm the environment. Additionally, biodegradable and non-toxic natural materials such as fiber, resin and proteins have exhibited insulating properties which are suitable for the substrate. So keeping in mind that the substrates used for the printed electronics. A substrate in the printed electronics can be made from the synthetic as well as from the natural material. On the basis for according to their application, they just prepare. They must be flexible, they must be having the stiffness and moreover having a high transparency, they must have the surface smoothness, they must have a low thermal expansions, heat resistance, low cost and so on. So these the primary requirement for the printed electronics is the lightweight substrate we will use, flexible substrate nowadays will use, and the other parameters we have to keep in mind whenever we prepare the electronic gadgets. In addition, different printers may have the different requirements. Certain have the thickness, certain have the flexibility and certain have the mechanical properties. On the basis of that, we define the various type of the substrates that will be used further. Moreover, the ink used in the printed electronics usually requires a treatment after the printing. This treatment can require the high temperature, chemical or UV radiation, or some substrate can be damaged by these treatments. So this should be taken into the account whenever we select the substrate for the printed electronics. So we define the substrate by the two types. First is the natural polymer substrate. This type natural polymer that will be natural and they must be prepared like a paper substrate, is an attractive alternative for the printing electronics, and it is a cheap, it is flexible, environmental friendly and biodegradable. Nowadays most of the sensors are prepared by using the paper substrate. So now the electronic gadget we will print on this paper and that can be used further. The disadvantages of the paper, that is a high surface roughness, moreover it having a high porosity, vapor permeability and the poor moisture resistance. So the properties of paper can be improved by coating or laminated. So we prepare an electronic gadget by the using the coated paper or the coated PET or the polymer. So another suitable natural polymer substrate is a nanocellulose, which possesses properties such as high transparency, mechanical strength, heat resistance, low thermal expansion and high surface smoothness. Other natural biodegradable materials which can be used as a substrate are the silk, shellac, gelatin and the starch, and by using this we prepare the paper. The silk is biodegradable, biocompatible and the non-toxic natural protein fiber materials that will be used for the printing electronics as a substrate. The silk is easy to process and has excellent chemical stability, mechanical properties and flexibility. Similarly, shellac is a natural resin exhibiting the biodegradability and high surface smoothness and high solubility in the alcohol solvent, and which makes the suitable for forming the substrate film. Another type of polymer substrates is the synthetic polymer substrates, in which we have a number of substrates which can be used. Like polymer films are the most popular choices for printed electronic substrate, but the manufacturing and operational of the polymer films are just is a very tedious task, and it is carefully designed and controlled in order to minimize their surface defects and distortions. Moreover, there are the different type of PET, PAN, PI and polycarbonates that are most commonly used as a synthetic polymer substrate. PET, that is the most popular polymer substrate, and nowadays it is used for the printing electronics, and it is we can print the many devices by using this. Now it is a optical transparent sheet, and it is flexible also, solvent resistance, low price, and it is having a dimension stability in a high temperature as compared to the paper. So we can use PET, which is a thin synthetic polymer for the printing electronics and to develop the electronic gadget on that. Now the PEN and PI on the other hand have the better heat resistance but the lower transparency and higher cost. PC has a high stability, low weight and good mechanical properties such as rigidity, impact resistance and the hardness. Moreover, there are the other methods also, PLA, PMS, PVA, there is a polycarbonate, and there are the other many polyglycol, and there are other examples which are biodegradable polymers and which can be used for the substrate material. Apart from that, substrates play a crucial role in the various electronic application, particularly in the realm of the printed circuit board. That is the conventional method we use for the printing electronics. In PCBs, printing electronic board, printed circuit board, that is a PCB, the substrates act as the base material on which the circuitry is constructed. Nowadays, we use the printing electronics. Additionally, flexible substrates, metal substrates, silicon substrates and the glass substrates are used in specific application that require the flexibility, heat dissipation, precise integration and the high transparency. So now what do substrates have to do with the printed circuit boards? That the printed circuit boards, we just refer the substrate as a base material where we just construct the circuit, and it is non-conductive material and which provide the mechanical support and the electrical insulation for the components and the conductive traces on the PCB. As you know that the most of the substrate used are the fiberglass, reinforced epoxy, laminate, commonly known, which is used commonly in the laboratories as well as in the circuit designing, is the FR4. That FR4 is widely used in the manufacturing of the PCB due to the excellent electrical properties, good mechanical strength and low cost. The electrical circuit consists then of the thin layer of the copper foil laminated onto the surface of FR4 substrate. So, conductive traces which form the electrical connections between the components of the PCB are etched onto the copper layer. So, substrates ensure that these traces remain insulated from each other and from the surroundings components, that preventing the short circuits and ensuring the proper function of the circuit. So we design the circuitry in such a manner so that the function of the circuitry body will be continuous and must give the proper result. So the in FR4, other materials like flexible substrate like polyimide or the ceramic substrates may be used as a specific application as required for the flexibility or the better result. So better thermal performance respectively. The choice of substrate depends upon the specific requirement of the PCB, such as intended as a operation condition as well as the cost condition. So now we discuss further the substrates for the printed electronics. Printed electronics involve the use of printing techniques, as we already discussed that these are the printing techniques we will use. By keeping in mind these techniques, then we select the substrate. Now you see that what are the printing techniques in which we discuss, like the inkjet printing, screen printing, flexograph and the groove printing. To create the electronic circuit on the flexible, lightweight and often the low cost substrate. So nowadays, if we talk about the printing electronics as well as the gadgets are using, and it has lightweight gadgets we are using, moreover flexible gadgets we are using. So keeping in that mind, and that particularly keeping in the application of the printed electronics, we choose the substrates accordingly. The choice of the substrate is crucial as it affects the conductivity, durability, flexibility and processing conditions. So what are the key factors in the substrate selection? That are the printing compatibility, that is the main point. The surface of the substrate must be according to the requirement. So it must, the surface roughness, ink adhesion and the porosity as according to the printing technique we were using. Next is the thermal stability, ability to withstand high processing temperature. Means whenever we are printing, if we can use this circuitry at the high temperature also. Mechanical properties, that is a flexibility, stretchability and the durability, that must be with the substrates. Nowadays we are having the wearable devices. So these wearable devices must have the flexible substrate. It must be having the stretchable and it must be durable. So if we are making the wearable devices, then we keep the substrates like silk, like cloth, like paper or like the PET, so that it can be used accordingly, like it will be flexible, it will be stretchable, it will be having the more durable. Another type of factors we will keep in the mind, that is the electrical insulation. It must be critical for the circuit performance. Another, environment impact, it must be biodegradable as well as the recyclability for the sustainability. Moreover, it must be environment friendly. So by keeping these points in the mind, then we select the substrate. Now flexible and extensible substrates for printing electronics, that will define. We have defined the two type of substrates also, like flexible and extendable substrate for the printing electron. There are three types. On the basis of that, we categorize the substrate into three types. First we define for the which will be used in the electronics. First we define the glass, second is the metal and third is the polymer. The first two type are rigid, means glass and metal are the rigid material, and glass is a non-flexible also, but polymers are the flexible material. So the metal foil is flexible and sustain high temperature, although it limited on the freedom to design and the high cost. Polymer composites such as glass reinforced epoxy laminated with the flame retardant, that is FR4, and have the largely used in the rigid printed circuit board, that is PCB. Non-reinforced polymers are flexible material and are more economical processed and give the greater freedom of the design, providing the studies and increasing intelligent printed electronic application and able to integrate in the complex system and environments. But the drawbacks, if we talk about, then it is having a low surface energy, which normally requires a prior surface treatment before printing and low processing temperature. So, the selection of the substrate must be keeping in mind its physical, mechanical, chemical, thermal and optical properties, and also it is important it must be compatible with the printing ink. It may be conductive, it may be insulating ink, it may be semiconductor ink. So, the substrate must be accordingly the ink we are using, it must be compatible with the ink also. So, if we talk about the polymer based substrates which are widely used to their flexibility, for the lightweight nature and the complexity with the printing processes. You can see that this is the polyethylene this is the polyethylene terephthalate, and it is having the low properties, that is having the flexible and moreover RFID tags, smart packaging and in sensor we will use. It is having a heat resistance like 150 degree centigrade. Another is PEN, that is a higher thermal and mechanical. It means that it is having a more stable than as compared to the PET, having the temperature more than the PET. It is also used as a flexible devices, and it is used for the solar circuit, moreover where we can just bend the circuit, then we use this type of PEN. Next is the Kapton, that is the polyamide, and that having the high heat resistance, and you can use this device for the temperature more than that of the 400 degree centigrade, and moreover it is having the excellent chemical stability, and it is having a high temperature for high temperature sensor, as it is having a high temperature, so we can use it for the high sensor temperature. Moreover, we can use in the aerospace circuitry also. Another type of polymers are polycarbonate, that is PC, which is a transparent and impact resistance, and it is a good flexible printed display wearable electronics. For the wearable electronics we use the polycarbonate, so that it can be it can be moved, it can be shaped, it can be adjusted accordingly. Another type of the polymer is the PDMS, which is a soft stretchable, moreover having the skin. We can use it for the bio devices. We can prepare for the bio devices by using this type of PDMS. It is you can see in the application that the skin sensors, bioelectronics and soft robotics. For this we can use the PDMS. Another is the TPU, which is a thermo, as it is the high elasticity and it is a waterproof durable, so we can use for the stretchable devices. Moreover, we can use it in the textiles and wearable devices. Another type of substrates are metal foil and the hybrid substrate for application requiring high conductivity and durability. So, copper foil we use, it is very simple, and on which we just we having the nickel foil on which we just draw the storage devices, but here we are using for the copper foil, that which is having a high conductivity, flexible and durable. It is used for the printed antennas and power electronics. Another is the aluminum foil, that is a lightweight also and corrosion resistance and cost effective. So, we use this aluminum foil as a substrate in the RF shielding, energy storage devices and many more. And the stainless steel foil, it is a strong flexible heat resistant, so it is used in the preparation of the sensor as well as the flexible batteries. Another type of the substrates are glass and the ceramic. The glass, we are having a two type, flexible and ceramic polymer composites, which is used for the high thermal stability and rigidity are where we use. So, if we talk about the flexible glass, then it is a bendable and it having a high transparency, heat resistant. So, OLEDs display and high surfaces, moreover the panel of the mobiles is also prepared by using this flexible glass. Ceramic polymer, high thermal resistance, good flexibility, power electronics, high frequency and circuit, maybe we will use this. Now, in the next lecture, we will discuss the compatibility between the printable material and the substrate, so that we can choose the substrate accordingly for the further application. Thank you very much.